Hello. In this video, we're going to go through 4.2.5, which is converting between standard form and scientific notation. And so for this learning chart, you're going to be able to go back and forth. So if you are given standard form, you're going to be asked to put it in scientific and vice versa. And so to convert from scientific notation to standard form, you want to first check if your exponent is positive or negative. If it is positive, it's going to be a big number, and negative is going to be a small number. And by small number, I really just mean decimal, so it's going to be a decimal version, but it's easy to remember that positive means big and negative means small. So you first check to see if your exponent is positive or negative. Then move the exponent number of spaces. So if it's a big number, you will move the exponent number. So let's say the exponent is 5. If it's a big number, you would move 5 spaces to make it a big number. If it is a small number, you would move 5 spaces to make it a small number. And going through the examples will be super helpful in a second, but we've got to get down like some steps first. And then vice versa, so if you're given standard form, just a regular number, to convert to scientific notation, we want to count the number of jumps to get the decimal from where it is to directly after the first number. And then we want to write it as a number times 10 to another number, the exponent. And this number needs to be between 1 and like 9.999. So this number has to be a very specific number for scientific notation. It has to be between 1 and 9.9 repeating. You can't hit 10, and you cannot go lower than 1. So if you need to pause it to make sure you have that, please do so, but I do want to go through some examples. So these first three we are given standard form, so given just regular numbers, and we want to write our numbers in scientific notation. And so what we want is we are going to kind of read our number left to right, and we are going to stop as soon as we hit a number, any number. So as I read left to right, I see a 4. And so what we want to do is we want to put our decimal right after that 4. So I like to draw a little arrow where I want my decimal to be. If you look at the second example, as I read left to right, like I don't hit any numbers. Oh, we're not counting zeros. I don't hit any numbers except 0 until the 3. And so we want our decimal after the 3. And then again, this last one, I immediately hit a number when I hit 1. And so I want my decimal to be right after that 1. So you just read it left to right, and you want your decimal to come right after the first number that you see that is not 0. Once you know where you want your decimal to be, then you are going to move your decimal from where it is to where you want it to be. And so for big numbers like this, our decimal is always at the end. It doesn't show up because it's a whole number, so we don't have a decimal. And so what we're going to do is I'm going to draw in this decimal at the end, and then you're going to count scoops. And so I'm going to scoop over each number until I get to the arrow. So I'm going to scoop 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And so it took me 11 scoops, so I'm going to kind of write that down right there. 11 scoops for me to get from where it is to where I want it to be. So now I just need to write it in that scientific notation. So the number times 10 to the power of whatever. And so our number is this number right here. And so you include all the numbers that are not 0. And so I have a negative out front, 4, and then this is where I want my decimal to be, so I'm going to put the decimal there, 0.56. And if you drew your arrow in the correct spot, this number, not including the negative sign, but just the actual number, will always be between 1 and 9.9 repeating. If you messed up and you have like 45.6, that's too big, so your arrow was in the wrong spot. You got to move your arrow to the right spot and then count again. So just double check that this number is in between 1 and 9.9 repeating. Then this times 10 part stays the same no matter what. That's the scientific notation part. It's telling you how many powers of 10 you are moving. And then your exponent is the number of scoops. And the only thing you need to be careful with is if this is a big number or a small number. And so all big numbers, ignore the negative signs. All big numbers are whole numbers. All small numbers are decimals. And so since this is a very large number, 456 billion would be a lot of money, our exponent is going to be positive. For all small numbers, our exponent is negative. So let's do another one. So I know where my arrow is supposed to be. Again, I just read left to right, and I know it needs to come right after the 3. So for decimals, they give you where the decimal is, and you're going to, again, count scoops all the way to where you want it to be. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, because you want it after the 3. So that was 15. So now again, I'm going to write my number using the numbers that I am given. And don't reorder these. It's 3.2. There's no negative out front, so I don't need a negative here like I did over here. Times 10 stays the same every time. And then I scooped 15 times, but this is a very small number. This is a decimal, and so my exponent needs to be negative 15. So if you want to kind of make a little note to yourself, this 11 is positive because we have a big number. And this 15 is negative because we have a small number, or a decimal. So let's do one more that's a little bit different. And so I know where my decimal is supposed to be. I know that my decimal is at the end because this is a large number, so I'm going to count scoops. 1, 2, 3, 4, 5, 6, 7, 8. But then when I go to write like the decimal part of this, when I go to write the beginning part, I usually use all the numbers I'm given. But if I just rewrite 1.23456789, that's not helping me at all. That's not making my work any shorter. And the whole point of doing this is to make our lives easier. Instead of writing this entire decimal, we're able to write it this way, and it makes it a lot clearer and easier to see. So if you have all numbers, we want you to stop after 3 decimal places. So stop after 3 decimal places. So that means I would have 1 and then 3 numbers after. 2, 3. And then when you get to the last one, you need to decide if you're going to round up or down. So for this case, I was going to write a 4, but if I look at the very next number, that's 5 or bigger. And 5 or bigger, we need to round up. So 1.235 times 10. And this is a very large number, so my exponent should be positive 8. So now we want to look at the opposite direction. How do we convert from scientific to standard? And I think this one's a little bit easiest because all we really have to do is we have to look at our exponent. And since this is positive, it's going to be a big number. And then what I like to do is I like to rewrite this beginning part to give myself some space because I'm going to end up moving my decimal and I need some room to do that. If it's a big number, we want to move the decimal to the end because all big numbers have their decimals at the end. All small numbers will have their decimals at the beginning. And so I'm going to move 6 scoops. So I'm going to start where it is and I'm going to go 1, 2, 3. And then I'm out of numbers, but I still need to do 3 more scoops. So just draw the scoops. And then any empty scoops you're going to fill in with zeros. Now you do need to rewrite this to make this clearer to me and Miss Lefke of what this is, what this number is, and where the decimal is supposed to be. When you rewrite it, do not write in that decimal. You moved it by doing your scoops. So you have 7,215,000. And then just double check this was supposed to be a big number, so that makes sense. Next one, same thing. So we are going to look at the exponent first, and since this is negative, this is going to be a small number. So rewrite this beginning piece to give yourself some room. But then small numbers need the decimal at the beginning, so I need to move my scoops to the left instead of the right. And I only need to scoop 3 times. So 1, 2, 3. And since we need a decimal at the beginning, I'm going to go ahead and write that in so I don't forget. For big numbers, you don't need a decimal at the end. You can put one if you want, but we don't really see that happen, so you don't need to do that. And again, you fill in your empty scoops with zeros, and you rewrite this so that it is very clear where your decimal is and what number you have. And our very last one, this is a positive number, so this is going to be big. I want to rewrite the beginning part to give me some room. And then this one doesn't have a decimal. So you see this is a whole number. So remember the decimal is right here right now. But we want to move it to make it big. So I want to move it to the end by moving it 3 scoops. And so I'm going to fill in all 3 with zeros and rewrite. If you learned this in middle school, you may have learned like, if it's negative, you go to the left, and if it's positive, you go to the right. But we do not teach it that way because that's very specific for whether you're doing this version from standard to scientific or standard. And they're backwards of each other. And so we don't want to teach left and right. We just want to teach big and small. So if you can remember, positive exponents are big numbers and negative exponents are small numbers. That's really going to help you out.